Okay, number 20, integral x cubed over square root of 1 minus x squared dx. How do we solve this one? I actually solved this in two different ways. So definitely there's more than one way you can do this. There's probably more than the two ways that even I tried, all right? So when I see this problem right away, I immediately see a something squared minus something squared, so I could do a trig sub, okay? That's not what I did for method number one, though. I instead tried to make a substitution. So I broke my rule, and when I broke my rule, if you were watching my previous videos, where I said, if you know a technique that is most likely going to work, you should just go with it and not think of whether another technique could be more efficient. I broke that rule, actually. I immediately started thinking, can I make a substitution? Because x squared, x cubed, I could break up as x squared and x, kind of like the other problem that we just did, if you're following along sequentially. All right? So, um, that's another method, but actually, I didn't even do that. So I'm let you be, actually, let me just expand this share screen. 1 second. That could be another substitution technique you could use. Instead, I made a different substitution and let u be square root of 1 minus x squared. Okay. So I square both sides before I differentiate it. So 2u du is minus 2x dx, and I could simplify it to x dx is minus u du. Okay. Again, actually, I guess I did have to break up this x cubed into x squared and x. Okay. So that's what I did here. And then x dx, I just found is minus u du, right? X squared, how do I get x squared? That is just 1 minus u squared from this line. Hopefully you see that. I didn't write it out explicitly. And then the bottom is just u, okay? So these u's would cancel, and then this minus sign could distribute in, so it becomes u squared minus 1. Now it's just the power rule here. So that's u cubed minus 3 minus u plus c, and then we back substitute what is u. U is square root of 1 minus x squared. Okay, so that's my answer using just substitution. All right. So I did, as I said, solve it another way, and I solved it with trig sub. Again, let me go back to the original problem first. Something squared minus something squared. I know probably a trig sub is going to work. Okay, so I set up the triangle. If you're not familiar with how to set up this triangle, I've said this many times if you're following along sequentially in the series. Please go check out my crash course in trig sub video where I explain how to set this up. Okay, so I need x. So I have the integral here. I need x to get x cubed. How do we get x? X is just sine y. And the dx is just cosine y dy. And then the square root term is just cosine y from the triangle. Okay, so substitute. That's what happened here. The cosines cancel. We have integral of sine cubed y dy. This is just a typical trig integral now that hopefully you remember how to solve. You save one factor of the sine, and then you change the rest to cosine. So that's what happened here. And then we let u be cosine y. Du is minus sine y dy. Substitute. And then this looks familiar, right? It's just the power rule now. All right, except in the method one, we directly back substituted. Here we got to back substitute twice. So u is cosine y. Okay. Now what is cosine y? Cosine y is square root of 1 minus x squared. And we get exactly the same answer. Not a surprise. All right, so basically, the more efficient method, especially in a time test, was to use a substitution, but maybe that was not as quite as obvious. So a trig sub could have definitely worked as well, as you just saw. All right. Again, you should, especially in a time test scenario, just go with your gut. If you're for sure and are pretty confident that trig sub works, just go with it. Like me, it's just for explanation purposes, I did it both ways, but it took me time to figure out what substitution could work. And it eventually did, but that extra time that I spent, probably I would have just solved the trig sub already. So I would, what's the saying? Do as I say, not as I do. So just go with the technique you're most confident with that will work, especially in a time test scenario.